Good evening, students. I'll start with the class. The next topic will be today, that is uniform circular motion. Okay, na? Now we have seen till now what is linear motion. Linear motion means obviously from the word itself line, so it's in a straight line. Okay, so we had seen what is linear velocity or what is velocity. Linear velocity means in a straight line. That was what? Change in displacement upon time. Linear velocity means change in the distance upon time. Now same way we have circular motion. Suppose obviously circular motion will be in terms of circle. If you are here standing here with 0, and if you are going suppose this side, you move this much. So this is the change in the distance. Then this is called as a circular motion. Uniform means always constant. So for uniform circular motion, what is the definition point of view? If any particle moves along a circular path, okay, if a particle moves along circular path with constant speed, so that is called as uniform circular motion. If it is not going with constant speed, no, then it is called simple circular motion, not uniform. Whenever there's a word uniform, that's why it is a constant speed. Otherwise, if it's simply circular motion, any particle moving in a circular direction will be called as circular motion. But with constant speed, then it is called uniform circular motion. So this is the difference between linear motion and circular motion. This is like straight line, this will be in terms of circle. Now how we had linear this displacement and all, this was displacement, this was time, this was velocity. Same way we have displacement, velocity and acceleration for circular motions also. So they are represented in a different way. Obviously now they will be in terms of angle. For this topic, now first thing what you need to know is what is angular displacement. It's nothing but same thing what I told you. This much, how much angle it has covered. Now from point A I want to go to point B. The angular displacement is nothing but displacement in terms of angle. Now this angle can be expressed in two ways. Till now in 10th standard and all we have only studied, I think, what is in terms of degrees. Any angle can be represented in two ways. One is in terms of degree, the other one is something called as radian. Theta can always be expressed in two ways. One is degree and the other one is radian. I'll tell you what is the relation between degree and radians, how to convert one from another. Radians, if I want to know, any degree is there, you just multiply it by pi upon 180. Example I'll give you. Suppose if I have degree, 30 degree I have. I want to write in terms of radians. This degree I want to write in terms of radians, suppose. So in the rough work column, what you do is take this degree. Radians means always in terms of pi. Whenever any this angle will have pi along with it, you know it is written in terms of radians. Whenever you have like this means degree. On top there's a circle. This everybody knows. Now radians means it should be having pi. So that's why we are multiplying it by pi upon 180. And then calculate. 360. So pi by 6. So 30 degrees same as pi by 6 radians. So same way you can calculate for remaining also. Any angle you can convert in terms of radians. So 45 if I have, just multiply 45 into pi upon 180 and then calculate. You cannot directly cancel here. So you see it will get 45 into 4. Or you can go for the table of 5. 5 nines are 45 and then you can do double. So pi by 4 you will get after cancelling. Suppose if you have 45 then 60 degree, again 60 into pi by 180. So this pi by 3 will get. Then 90 degree will be, you can check pi by 2. Then 180 degree will be just pi. And 360 degree will be 2 pi. One whole circle, you know, definitely theta is 360. And in terms of radians, this whole thing is 2 pi. One full circle will always be 360 degree or 2 pi radians. The angle for a circle is 360 or 2 pi radians. Now, if you want to calculate the angle in how much distance it has covered in terms of this, I've given already the diagram. Just I already given, just put over there only. If this is theta, this is suppose arc length. How much ever distance it has covered, then you can calculate this theta. Any circle definitely will have a radius. So R is the radius. Okay, you can take L as the arc length. And theta is the angle. What is the angle formula always? Arc length upon radius. This is the formula which you should be knowing. Any angle you want to calculate, that will always be arc length upon your radius. And this will always be given in terms of radians, not degrees. Theta will be L upon R, radian. Radians is a unit for theta. I told you, two ways we can write. One is in terms of degrees and one in terms of radians. Radians means actual distance wise. So theta will be, so this is basic normal one, and this doesn't have any dimension. Means what? M, L, T, both, everything will be 0. Because what will happen? This is also in terms of length, this is also in terms of length. Length and length will cancel and become 0. So radians has no dimensions. So what is angular displacement then? So we want to know delta theta. Then it is always delta. We don't use this displacement letter, we use as S. So instead of L, it uses S. So this is displacement. Same like linear only, but only thing this will be in terms of theta. For displacement, we'll be normally using the letter S, not delta L. You can use it as delta S. S is also the arc length only. Huh? L also represents length and S represents the change in length, final minus initial. So if you know the displacement, you can always calculate velocity. So how we had linear velocities, then we'll have angular velocity. Just give me 1 minute and just be back. The next topic is angular velocity. Velocity, you know, is nothing but change or change in displacement upon time. Any change in length upon time will always give you velocity. So what difference will be here only in terms of angle? So angular velocity is nothing but change in angular displacement per unit time. Here we normally use for linear velocity, we use the letter V. But for angular velocity, we will not use V. We will use it as W. This is angular velocity upon delta T can change in time. Which is also same formula for average. The average velocity will be delta S upon delta T. average velocity. And what will be instantaneous velocity? This is always S final upon S initial upon T final, same like linear, minus T initial. And this will be limit T tending to 0, delta S upon delta T. So it can be same way written as dt upon this ds upon dt. Or I can say d theta upon d. This you can write as theta for displacement, no? Theta final you can write. It's change in angular displacement. So angular displacement will be delta theta. Just correct this one. This is delta theta upon delta t. So theta final minus theta initial upon t final minus t initial. And instantaneous means we have to find a derivative and then calculate. So suppose if I give an example, if theta is 2t square plus 2,
Miss, what is that? Instantaneous velocity is equal to?
limit t tending to 0, this is just a formula. And if t is very less, no, then we directly write this. Actually, this is not required. More of this is the formula you need to know. W instantaneous, we can write it as d theta upon dt. This is what exactly we have to know.
Okay, Miss.
So this will be 10 radians given to you. It has started with 0 and then went to 10. So that is the angle 10 radians. This is your theta formula. Find angular velocity at t equals to 2. Or first I'll take average in 2 seconds and at 2 seconds. You will see both the difference. Find an angular velocity. The first question is in 2 seconds and the other one is at 2 seconds. In 2 seconds means the whole range, and at 2 seconds means exactly at one point. Whenever you have to find exactly at one point, it means instantaneous. And in 2 seconds means always your average. So if I have to calculate for this, so change in time will first you will always start with 0 and then you went till 10. So theta final one was 10. So this will be 10 minus 0. So in 2 seconds means initial would be always 0. So this is direct formula. If you want, if this also is not given, no, still you can calculate. If this 10 radians was not given, you just calculate theta. This theta I can always calculate as 10. Put theta. What is the formula? At t equals to 2, what will be this? 2 into 2 square plus, so that will be 8 plus 2, which is 10. And at t equals to 0, what you'll get? Obviously, this will not be this, no? I, oh, so that is coming as 2. So we'll have to take this as 2. So at t equals to 2, we'll have to calculate. Don't put on first only, wait. 1, your initial time, and that is your final time. So we'll see what was the angle at time equals to 0. So put t as 0 and see. This will be 0 plus 2, that will be 2. So this is final and this is initial. This will be 8 by 2. That will be 4 radians per second. So even if this is not given, still you can calculate.
So how you got that 10?
2 square will be how much? 4. 4 to the 8 and then plus 2.
Miss, can you
Okay.
please explain it again?
Okay, wait. If this diagram also was not given, no, this theta is given. We know what is the formula. V average is theta final. What is the delta theta upon delta t? Now this is theta final minus theta initial. That's nothing but t final minus t initial. So now this was a circle. From 0 to some point you must have gone from t equals to 0 to 2 seconds. So I want to check now how much it is from 0 to 2. What is the average velocity, that is W. Why we are using W? Because we are doing for circular motion. So first we'll check for either final you can calculate or at initial, no problem. So first at t equals to 0 we will calculate. So that's the initial time. So take this formula, theta is what? 2t square plus 2. So put t as 0. So this will be 0 square. 0 into 2 will anyways give me 0 plus 2, that is 2. So at t equals to 0, theta equals to 2. Now same way I have to calculate for my final also. So final at t equals to, why I am taking t equals to 2? Because in 2 seconds. So from 0 to 2 we are calculating. If it was given as 3, we have to take this as 3. So at t equals to 2, calculate your theta. So 2 square will give me 4 and 4 will 8. So that will be 10. Always it is in terms of radians. So want you can write a unit also. Now substitute in the formula. So V average will be V final. Where is the final? 10. What is the initial? 2. Sorry, theta. Time will be 2 minus 0. 8 upon 2, which is 4 radians per second. Why? Top part is radian, down with time. So that will be second. Now clear?
Yes, Miss.
Now next one, we have to find instantaneous velocity. Instantaneous means always we have to differentiate. So for instantaneous velocity, W instantaneous will be, so we have to differentiate. Take this thing, whatever equation has been given, and now we have to find a derivative of that. So d theta upon dt, this will become after differentiating always. Now this 2 is coefficient at the side only. What is derivative of t square? I must have given to you all in terms of s. Or I think t only it was given. What is derivative of t square? N t raised to n minus 1 formula.
2t.
Yes, so that will be 2. And derivative of constant is always 0. Any single number is at 0. Now d theta upon dt is 4t. At t equals to 0, 2 you calculate because it is asked at exactly at 2 seconds. If it is asked at 4 seconds, you have to take 4. Then calculate d theta upon dt will be 4 into 2. Again now like you can get different also. But now same you are getting. 8 radians per second. Not necessary you have to get the same. You can get a different one from average and different for instant. So if instant, then you have to always find derivative. If average, then use the previous formula, direct substitution. Then you have something called as time period. It's always used as letter T. So time taken for one full revolution. It's one full circle. If you start and end up till here, no? One full circle is called one revolution. So time taken for one revolution is called as one time period. Always denoted in second. Same we might have frequency. Frequency is nothing but this symbol, okay? Number of revolutions, how many revolutions you take in one particular time. Number. And T is nothing but what is the relation, or frequency is always 1 by 2. If frequency is on top, time will be there. So relation between frequency and time is always 1 upon the other fellow. So this is in a basic test. Suppose if you have one angular frequency in terms of circular motion, angular frequency will have a different formula because you have to write it in terms of radians. And the word used instead of this, it is W. Not exactly W, it's like omega, something like this. Two pi upon T. In terms of frequency, it is same as 2 pi. We only use for problems point of view to the relation between time and frequency. Angular frequencies 2 pi means what? I told you one full circle is called 2 pi radian, means 360 degrees upon how much time has been taken. So number of revolutions per unit time. Next we'll see what is the relation between linear velocity and angular velocity. You have a circle, you are here, you reach here. Now suppose this is angular displacement. This is delta S, change in the arc length. You're from here, you're going till here. And suppose this is your radius. This is nothing but distance covered, or also called as displacement. Delta theta is nothing but angular displacement. And R is your radius. This is like a small derivation to derive what is the relation between distance and this. What is that? Linear velocity and the angular velocity. So we know what is the formula for angular displacement. Angular displacement is nothing but delta theta is nothing but displacement upon your radius. This we already know. Angular displacement formula. Change in the arc length upon your radius. Now what you do is, with respect to time, we'll see now. So we'll divide both sides. Divide both sides by delta t. This side also will divide by delta t. So it will get delta theta upon delta t. If nothing is there, we can just reverse it.
Miss, why are we dividing it with delta t?
Because we want to derive in terms of velocity now. Velocities will always be in terms of time, no? Change in angular velocity, or this angular displacement upon time. We want time. What is the formula for velocity, or this any velocity? Change in the theta upon time, or change in displacement upon time. So here time was missing. So that's why we are introducing time, so that we come to a
Okay.
conclusion of velocity. So if you see, this is nothing but, now we'll just remove r at the side. And we'll write delta s upon. So this is nothing but change in the angle upon time. And if you see, this is nothing but displacement upon, or change in the distance upon time. So what is the letter for change in angle upon time? We don't use v. This is nothing but this angular velocity. Angular velocity means w. and this is nothing but, if as it is, change in distance upon time is nothing but your linear velocity, that we'll use as v. For angle we always use w, and for distance we always use v. So this is the relation between angular velocity and linear velocity. So this is nothing but your linear velocity, and this is your angular velocity. Also it can be written as v, you can keep up, r you can take on the other. V is equal to r into w. Write this and we'll solve two problems based on this. Just before solving a problem, one more formula I'll get. You know what is called as a centripetal acceleration. So whenever we are done problems, I suppose a stone is thrown up, okay, or whenever you throw anything in space, you know that always there's a gravity which pulls it down, okay. The same way, suppose if any particle is moving in a circular motion, now there's a particle which is going on circulating, so there will be some kind of force which will be pulling it, like trying to pull it towards the center of the circle. Like how we have acceleration due to gravity, same way we have some kind of force which is pulling towards the center of the circle, like how center of the earth, same way center of the circle. So that is called as a centripetal acceleration. In terms of explanation, if you want, suppose a body or particle or any body is moving in a circular path, suppose a body is moving in a circular path, it is acted upon by an acceleration along the radius of the body, suppose along the radius towards the center of the circle. So it tries to pull somebody towards the circle. So that is called as a centripetal acceleration. And that acceleration formula is nothing but r into w square. So r is the radius and w, you know, is definitely a angular velocity. So based on whatever we have done, we solve two problems. This also you have to know. First question, a body of mass 10 kg revolves in a circle of diameter 0.40 meters, making 1000 revolutions per minute. Calculate linear velocity and centripetal acceleration. Okay, so this is the question. The mass of a body is given to you as 10 kg. So kg is always you write in terms of grams. So 10 kgs mean I can keep it that way only, no problem. Or in terms of grams if you want. 1000 grams will make 1 kg. Now diameter is been given, but we want radius. You know, radius is always half of your diameter. So substitute d is nothing but 0.40 upon 0.20 0.20 meters. Now what all we have to calculate? Linear velocity and a centripetal acceleration. Now there's an angular speed we have to calculate before that. Angular velocity. Angular velocity formula is 2 pi v. This is for angular. Wait, and the student is okay. This is frequency, and just correct it. A student had sent me this problem in the note to someone to solve. Just correct it on your notebook. Angular frequency, not speed. That's what I was wondering. What has been given? Garden angel. It's angular frequency, not speed. This is the formula for angular frequency, which I've already given. Omega is 2 pi nu. And what is this frequency? Nothing but revolutions per unit time. How many revolution it makes in certain time. So now we want to calculate this angular frequency. So that will be 2 pi. How many revolutions it is making? 1000 revolutions. And how much time is it taking? In full time, you have to take it as per minute. So 1 minute means Always I told you time we have to take in 60 seconds in terms of seconds. So 1 minute will take how many seconds? 60 seconds. So it will be 60. Why am I calculating this? Because the formula is, just now we have seen, V is R into W. So we have to calculate linear velocity. For that we need to know what is W. And W in terms of this is here already. So first we'll calculate the value and then put here. Because radius we know, but W we don't know. But our aim is to find V. First, that's why I'm calculating W and then finding linear velocity. So in terms of like this, we calculate. So anyways, your teacher has kept like that only. So 100 pi by 3. Radians per second. And now we'll calculate linear velocity. So the formula is V is equals to R into W. Relation between linear velocity and angular one. Now substitute. This is 0.2 meter and W is 100 pi by 3. So if you multiply by 100, this will move on to 2 decimal points. So this will be straight away 20 pi by. If you multiply it by 100, you will get like this. This will be again. This is linear. So linear means meters, meter per second. And angle means always radians per second. In the last part, what has been asked is centripetal acceleration. Now substitute the value. R is again 0.20. W is how much? Square it is. So square all the terms. So that will give me square means multiplying it by 2 times. This will become pi square. This will become 3 square. So that is 9. So this, if you use here, this will become 20, 2 decimal points into 100. So this, if you multiply, 2000 pi square upon 9. And acceleration is always meter per second square. So this is your answer. One more question. circular groove of radius 12 centimeter moves along the groove steadily and completes 7 revolutions in 100 seconds. Calculate angular frequency of speed. Second one, linear speed. Okay. And third one is centripetal acceleration. Same like the previous one, only we have to solve. R is how much given to you? 12 centimeter. Revolutions how many? 7. Time is about 100 seconds. Now this is given in terms of centimeters. This always has to be in terms of meters. Again, this has not been done. I think your teacher has directly taken as centimeters only. This has to be in meters, distance. So if it's given in terms of meters, you have to take as meters. But if given in terms of centimeters, then always convert. R will be always 12 upon 100. That will be 0.12 meters. First one, you have to calculate angular frequency of speed. That's nothing but your W, 2 pi nu. So this is pi. And this is how many revolutions per unit time. So this is 7 upon 100. Now here no need to change. Last time it was 1 minute. That's why we have to write 60 seconds. So directly here it is 60 seconds. So it will remain that much only. If you want to keep it in terms of this, so this will be 14 pi upon 100 radians per second. Now it depends on your teacher's mode. Now she has done here, pi has been taken as 22 by 7. Whenever you all want, you'll take 14. Sometimes what is the value of pi? 3.14, or it can be taken as 22 by 7. In one problem the teacher has kept in terms of pi, and one she has kept in, she has solved. Now you'll ask your teacher what is to be done for exam, whether to keep it like that or whether it is to be solved. If it's to be solved, then you have to substitute 22 by 7 and then calculate. So 7 to the 14, 44 upon 100. So this will become 0.44 radians per second. because in the previous problem it was kept as pi only. So there also, if you want, you can substitute as 22/7 and then calculate. Or you can put it as 3.14, whichever value you want to put. Then linear speed I want to calculate. So definitely the relation between linear velocity and angular velocity will be this. So V, we have to calculate. R, we have to take as 0.12, and then this will be 0.44. Then calculate and write your answer. So that will be 0.12 into 0.052 meters per second. And last is your centripetal acceleration. Zero point four square. Into 0.193. It will be 0.023 meter per second square. Okay, so this is about a uniform circular motion. The next topic is projectile motion. So whenever you throw an object in air, I told you there is always a gravity which will act upon it. Okay, so projectile motion will always be motion under gravity. So what is going to happen is, whenever you have something, you are there, the ground floor, suppose, and you are throwing something. If you start from here, if you throw, it will go up like this, and it will come like this. It's not that you are throwing it straight up. Suppose at a like this, at an angle. If you are throwing, even a cricket ball, if you throw like this at this angle, it will always follow like this path. So an object thrown in space, the definition will be there on your textbooks, or even in the class they'll give. Okay, so any object when thrown in space will move under the force of gravity, and that is called as a projectile motion. So this path, particular path, is called as a projectile motion, motion under gravity. So that much is enough to understand. Any object in space will always be following motion under gravity, and that is a projectile motion. And the path followed, this path is called as your trajectory. Now, any object moving will always have some velocity. So it will always have an initial velocity, okay, So here any object will always have some initial velocity. Not necessary it has to be from the ground, it could be from anywhere also. It will have initial velocity, and just before ending it would have a final velocity. And the words used for initial velocity is u, and for final velocity is always v. So now consider this is thrown at some angle theta, and obviously I am throwing it with some force. Now any velocity flowing, I told you it will always has some components. Any velocity vector, any vector will always have its x component and its y component. Suppose if this is theta, you always have vx and vy. Same way if you have this as u, it will always have ux and uy. Any vector will always be resolved into two components, ux and uy. So same way every point, like every vector can be resolved into two components. So this is your ux and this will be your uy initially. Now at this point, suppose there is one more point you consider at point 2. So again this is like an arrow, even this fellow might have. If you are taking another point, this is like the arrow with reference to that, like this. So every single point will have some components. So if you here again, now over here exactly at up point, the velocity will be definitely 0. It will go on reducing and then at some point it will be 0. Then again it will flow like this. Again it will come here, it will go like this. So here this side the components will go like this. If this is your main vector, so now this is your main vector, so your components are like this till you reach finally your final point. See, you are throwing it with some speed, very high speed. What will happen now? Gravity will start acting on that stone. Why does it come down? Because the speed will start reducing. You are throwing it with a very high speed. Still, it doesn't keep on going or continue outside your space. Definitely, it will go. Then the gravity will try to pull it down, pull it down. At some point, the velocity will become 0, and then it will come towards the ground. So what is going to happen? This will have components. So if you are considering this as your v, so this will be your vx, this will be your vy, vx, vy, vx, vy. So like this, every component. So this will be your vx, will be your vy component. Vx, x-axis direction. This is your y. Vx, your vertical component is always your y, and horizontal component is always your x component. Every single vector. I have randomly taken the points, but every point will have a vector. Now over here, theta is nothing but an angle of projection which I am throwing. Okay. Now, can anyone tell me in which direction does the gravity act? Gravity due to Earth is acting in which direction? Horizontal direction or vertical direction? The acceleration due to
Vertical.
yes. So there will be always accelerate downward. So gravity will act only in the vertical direction. Acceleration due to gravity always in vertical direction. So therefore, acceleration in horizontal direction will always remain 0. Acceleration due to gravity. Acceleration due to gravity in horizontal direction is always equals to 0. So in terms of components, if you want to say, what you have to say is nothing but your AY is always what? Negative direction is obviously it's minus 3. And your AX horizontal component is always 0. Because gravity always acts in vertical direction. It will never act in horizontal. If it was acting in horizontal, even while standing also we would be pulled sidewards. We would not be pulled towards ground. We would also be pulled towards sidewards and will keep on moving on the earth whole time. So horizontal gravity is always 0. Acceleration due to gravity is 0. So when can acceleration be 0 in terms of velocity? Can anyone tell me what must be happening to this? When we say acceleration is 0, what is the relation with the velocity or with the speed?
When the velocity is constant.
Yes. So velocity is constant. So it means what? Acceleration or AX is 0 means so velocity in horizontal direction. We are talking about horizontal. The moment your speed, you are not increasing also your speed, you are not decreasing also your speed. That means you are not changing your acceleration. So that's why it is 0. Imagine you are going on bike, you are just constantly going at 40 from one point to another. So obviously you will say, I never accelerated my bike. My acceleration was 0. So velocity in horizontal direction is always constant. That's why you get is 0. So this Vx will always remain same. Suppose if it starts with 4, no? Consider if Ux it has started with 4, your vertical component was 4 suppose. Here also it will remain 4, here also it will remain 4, here also 4. Everywhere your horizontal component will remain same throughout the projectile motion. Very important. After this you can write horizontal component of velocity remains same throughout the projectile motion. Never it will change, huh? Because there is no acceleration only in the horizontal direction. What changes throughout is only your vertical component, Vy. Suppose if we had started this with 4, this also started with 4. This will keep on reducing, suppose. Then it will become 0. Then here it will become again 1, minus like -1, -2, -3. Because it's in the negative, so it's understood. It will be this, and then it will go back, and then after resting, it will become 2. So your vertical component changes. After this, you can write vertical component is what? Vy. So it, from initial point keeps reducing, then at maximum height, Vy becomes 0. Okay, and then drops down. So then then increases. Again we want to say and then increases. And then increases till it reaches the ground. So at this point, can anyone tell me the components? What will be the value of Vx component and Vy component? Just now I told you already Vy is 0 at the maximum point. What about x component? What will be the value of x? What is Vx at maximum height? Just look at the diagram only and tell me, no, what is Vx at maximum height?
0.
What did I give you all? What happens to Vx throughout the projectile motion? Horizontal component, is it changing?
No,
See,
miss. It's
yeah,
4.
yes. So even when I mention V as 0, so it's nothing but Vy is 0. But Vx will always remain as 4 only. It will never change. Overall, your velocity they say is 0. This. But your Vx component will always remain 4 throughout. So at maximum height, that's why I specified Vx as 0. And right, at maximum height, Vx will not be equal to, it will have some value. You don't know how much. Now I've given you example as 4. So it may be some other value. At maximum height, only your y component becomes 0 and x component must be something else. Now we'll see what happens to the x and y. I'll give you as a table. This is x component, these are y component. Let us see what is initial velocity first. So initial velocity is ux. In terms of formula, obviously, if this is your u, if the initial velocity u, then whatever is attached to theta, the component is always u cos theta. Your horizontal component is always with respect to theta, it will be cos theta. Same way, your vertical component for y, uy will be u sin theta. This component is always cos theta. Away from theta is always a sin theta. We have solved problems also in the previous class with horizontal and vertical component. Whenever you want to find vertical component, you have to always use your main vector and sin theta. The horizontal will always be your main component into main vector into cos theta. So this is your initial velocity. What will be acceleration? Acceleration due to gravity. Ax will always be 0 and Ay will be always minus. And right over here also in case this always remains constant. And this is A. So this is very important. So if there's a question, suppose at maximum height, Is the speed of the body 0? Then you have to say no, only Vy is 0, Vx will be same as your initial. Whatever was your initial will remain throughout, the same as your Ux, which is constant. Because that horizontal component will never be 0. So this is what main thing you have to remember under projectile motion. Your x component will not change, and for acceleration your x component is 0. This is minus g. Okay, this is one which will change. Now there are some derivations. First one is for the time. How much time it takes for the flight. Flight in the sense for the motion. First one is time of flight. Draw simple diagram. So it will always start with theta. It's like a main vector. This will always have components. At this point, this will be a maximum height. Like time taken will be from here to here. This to this will be t. This also. So time taken to reach up will exactly be same as time taken to reach down. Now. That anyways I'll give you. Time taken to reach up at the main point, maximum height will be same as time taken to reach down. Just name it as A, B, and point C. So now we'll consider the motion from A to B. So we will write all the components first. So this is obviously your initial velocity. It starts with u. So this fellow is your u starting only. So it will always have two components. I told you this will be ux cos theta or u cos theta. Your vertical component will be uy, which is u sin theta. Here it will be Vy and Vx. Ux, Uy, same way Vx and Vy. We'll write all the things from A to B. No, the initial velocity is your u. So definitely it will have two components. It will be horizontal component. Ux will be u cos theta. Uy will be u sin. The same way we'll have a final velocity. So from A to B we are considering. So final will be here. So this is at point A. Final velocity will be at point B. So that will be V. So that also will have two components, Vx and Vy. Vx will be same as what? Vx cos theta or u cos theta. Why? It will remain same as this. That horizontal component will never change. Vy will be obviously 0. At this point, Vy will be 0. But Vx will be same as what you had started before. This and this will always be same. At this point, this fellow and this fellow will always remain same. Then acceleration due to gravity, Ax is 0 and Ay is minus. So we know all the components: acceleration, velocity, initial velocity, final velocity. So now let us calculate the time. So for that we had 3 formulae, kinematic equations. So out of that, the first equation which we can use is V is nothing but u plus at. We have always studied the three equation kinematic. V is equals to u plus at, then S is equals to ut plus half at square, and then the other one is V square is equal to E square minus 2as. So one of them we can use. Now we'll use whichever component we want. So we can use the y component one because it will be easy. This fellow is 0, no? We'll find for Vy. Time will not have any component. Time is not a vector. Huh? So I'm using y component for all of it. So now I know what is Vy is 0. Uy is what? U sin theta, vertical component. Ay is how much? Minus. This is 50. Now I want to calculate time because my this derivation is to calculate time of the flight. So this part I'll bring this side first. This will be minus u sin theta plus into minus will give me minus. Now t there only. Minus minus will cancel. U sin theta upon g is the formula for time. You have to by heart this for calculation of problems also. There will be problems, you have to calculate the time of flight. So in that case, you have to know what is the formula for time of flight for projectile motion. That is nothing but u sin theta upon g. This is for normal. This is for A to B. Huh? Now, next part, time taken to go from A to B obviously is equal to time taken from. So you don't have to sit and calculate again. Time taken to go from B to C. So obviously, if this is t, that will also be t. Total time will be 2 times t. Therefore, time of flight will be 2 times t. It will be like doubled. From here to the main maximum height, you are taking 10 seconds, and obviously 10 seconds to come down. Now you got it 2 into 10, 10. Now substitute this. So 2 u sin theta upon g. So this put it as capital T. This is the main formula for time of flight. You have to know this for your problem. Anyone who is not understood, you can ask. You can calculate from A to C also, no problem. Directly also. This is easier way. Next we'll see for maximum height. Next derivation is for maximum height. Same thing, we are considering for the same, okay, starting only from A to B. Consider motion from A to B. So everything, all the components which I have given will remain the same. No need to write again. I'm just giving you. X is equal to u cos theta. This is for initial. Uy is equal to u sin theta. This is u. For v it is Vx is equal to u cos theta. Vy is 0. And for acceleration, Ax equals to 0. Ay is minus. This data will remain the same everywhere. For projectile motion, this is same. So the same components will come here. So now we want to calculate height. Height means what? Distance. Obviously now we cannot use the first kinematic equation. That was v equals to normal one, no? Both were in terms of velocities. V was u plus 8. So obviously this is not having any distance in that. We want to calculate distance. So you can use the other one. V square is equals to u square plus 2a. Second one also we can use, but there we don't know time. Time again what we have calculated we'll have to put there. So this is the best option because here we don't have time. T is not there. So we can use this one. We know what is u, we know what is v, what is a also. So same thing I'm using the y component. So that will be 0, vy is 0, uy is what? U sin theta. And this will be what? Square is this, the whole square. Now 2, a is minus 3, ay is minus 3. And s will keep like that only because we have to calculate. Now when you open up the bracket, square will belong to both the terms. So this will become u square and this will become sin square theta plus into minus. And this will bring it on the other side. Minus minus will cancel. So u square sin square theta upon 2 which is here. So which can also be written as h. Distance is nothing but height. So u square sin square theta is the maximum height. And the third one is the range. Range means total from initial to final what was the discovered. So in the diagram you just write like this and click. Range will be from initial till the final point. This is h and this is time. Capital T then full. So this is time of the flight, this is maximum height, this is range. We'll derive horizontal range. Horizontal, no? We're calculating here. So that's why it's called horizontal range. Now for horizontal edge, definitely we need from A to C. So we'll see what is for initial component. This horizontal will be what? U, X will be U cos theta, Uy will be U sin theta. Then this is initial. Final means, okay, we are considering right there, considering motion. From A to C. From here to here we are calculating. So now initial point is A and final point is C. So this is point A. Same diagram, okay. The final velocity will Vx cos theta and Vx sin theta. See, whenever we consider final velocity, no, it's never like after coming to ground and then. After coming to ground, definitely it will become zero. But whenever you are asked to calculate final velocity, you have to assume it is just before reaching the ground. Like just before hitting the ground, what must be its velocity? Because there's no point after reaching the ground calculating. No, everybody knows that after reaching the ground is zero. This is V cos theta, this is V sin theta. Acceleration at point C. So here this will be zero, this will be minus. This will never change. Initial and final will never change. This acceleration, only this may change at which point we are calculating. On top, maximum, this would have been, this is y, no? This would have been 0 over here. But now we are calculating at point C. So we'll see which formula can take. Can use the second one. So we'll use x components now because acceleration we can put as 0. Over here is x. This will not have. So this will be ux times ax and c. So we'll substitute for x component. So you know that ux is nothing but u cos theta. This is t. This is half. Ax is 0. What you will get? Right now this distance we are calculating. U cos theta. Just now we had calculated the time to substitute. This time will be full time, huh? Just right here. T is time of flight. So it's like assumed to be the capital T. So 2 times and this part will anyways be 0. Half into 0 into anything will be 0. So U into U will give me U square. You can write initially also. Now this S you can use it as R for range. Distance, because we are calculating range, instead of S you can use like R. Now this is the actual formula. Before that we'll write like this: 2u square sin theta. I'll write first because it sounds nice to say sin theta cos theta. Now this is the formula which you'll have to remember for problems point of view. But if you want to derive, okay, till your range formula is this. But for derivation point of view, we should know one formula, that is 2 sin theta cos theta is always equals to sin 2 theta. This is in mathematics and trigonometry. We will come to know 2 sin theta cos theta is always equals to sin 2 theta. So this will go 2 sin theta cos theta. R will be written as 2 u square sin 2 theta upon. This is for derivation point of view. But if you want to use it to calculate range in problems, you can use this. Otherwise, if you use this, again you have to know what is sin 2 theta. Again, you have to split it as sin 2 theta as 2 sin theta cos theta. So it will become a problem. So I'll just calculate one problem and then wind up. Question is, a ball is thrown five meters per second at an angle of projection 37. Find time of flight, horizontal, the height and the horizontal range. Also find initial and final velocity in vector form. Okay. Now remember, this now is a typical angle. Before solving the problem, I'll tell you, whenever this, they'll give either two of the options. One is 37 degree and one is 53 degree. So if you have 37 now as your initial this as a theta, and you might have, instead of that 57, they might give you 53. So whenever you have this now, just remember, you always take this as 5. It's a fixed triangle, okay? They're standard triangles. This value hypotenuse will always be 5. The side of 37 adjacent to that side will always be 4, and this will be 3. You write on top of the page and keep, or wherever you want to write and keep. 53 no, over here this will always be 3, this will be 4, and this will be 5. Why we have to know this? It helps us in finding what is the value of sin theta and cos theta, because we will have to sit and calculate. Otherwise, what is sine of 37, what is cos of 37? Using triangle method, it will be easy to find. So in this case, you tell me what is cos theta and what is sin theta. This is my theta. So as per this, cos theta formula is always what? Adjacent upon hypotenuse. So adjacent side is always 4, hypotenuse is 5. So value of cos 37, 4 by 5. Same way, what is sin theta?
Opposite of hypotenuse.
That will be 3 by 5. So cos of sin of 37 will always be 3 by 5. You want to by heart doesn't matter, or if you know this logic, you can always calculate. Same way it will work for this one. As of now, we don't need this, so we will not calculate and simply get confused. So this is how it works for 37. So now what they are trying to tell us is, now there's a ball which has been thrown and this angle has been 37. So this will be a u. This will be a ux. This will be your uy. And u is given to me as 5. This is the only data given to me. Now, as per the formulas, I have to find the time of flight. So time of flight is T is 2u sin theta upon 2. U is definitely 5. Now, just now I told you how to find sin theta. Sin theta for that was sin of 37. You just substitute first, okay? Gravity, you can take over there. Gravity due to acceleration 10 meter per second square. If they don't give, you can take it as 9.8. 9.8 or 10 option. Now, for simplicity, we'll take it as 10. And here we have to take positive, because time can never be negative. Even though gravity, we know it's acting in the negative direction, but after cancellation and all, already we had got this as plus g. So g anyways you have to take plus 10. Otherwise time will get negative. This will be 10. And now sin 37 as per the triangle rule, we have calculated to substitute that. So opposite upon hypotenuse was 3 by 5. The value of this substitute as 3 by 5. And now calculate. This and this will cancel. 2 5 are 10. So 3 by 5 is the answer. 3 by 5 means 0.6 seconds. So this is your time of flight. Anyone who has not understood how to calculate time, you can ask.
Teacher,
Otherwise,
how you got U 5?
huh?
How you got U as 5?
Check in the question. Initial speed. Whenever
Sorry.
the ball is thrown with a speed of 5 meters per second. So that will always be your initial speed. Now, next one is, or they will give you standard angles, okay, like 45. So you know sin 45 will be 1 by root 2, or sin 30 they might give you. If those standard angles are given, then it's very good. You can directly, but 37, then use that triangle method. Or 60-degree also will be easy to calculate. So h will be for your height, maximum height. So u square sin square theta upon 2g. So again, this is very simple. This will be 5 square. Now sin theta already you know is 3 by 5. But then square it. 2 into 10. Then calculate. So this will be 25. This will be 20. This will be 9. Square belongs to both the terms. Huh? Then 9 by 20. Then you calculate and write how much it is turning out to. That will be in terms of meters. Huh? So 0.45 meters. And the third one is range. So for that you use that problem formula which I gave you now. 2 u square sin theta cos theta upon so this will be 2 5 square sin theta was 3 by 5 cos theta is obviously 4 by 5 means sin 37 for this we want to put first. So angle is 37 degree. This is also 37 degree upon g means 10. So 2 into 25 into 3 by 5 and this cell is 4 by 5. And then you calculate. So this will give you 12 by 5. 5 is that 10 2.4 meters. So this is how we have to calculate your normal range and all by just putting the angle values and then calculate. You just have to know what is your initial speed. Then you can calculate. Now comes the vector part. They have also said initial velocity and final velocity in terms of vectors. So vectors means always the components will have to write. So this is your this. I told you this is your theta. This is always your u component vec and this will be your u1. So vector will always be what? Vec. So this is your initial velocity in terms of vectors. So first what I'll do, I'll calculate what is ux. Ux is u cos theta. So for this it is how much? 37 given to me. To calculate ux, so this is 5 cos 37. That will be 5 into cos of 37 was 4 by 5. So ux, I got it at 4. Same way calculate your y component. So this will be uy, that is u sin theta. That will be 5 into sin 37. That will give 5 into 3 by 5. So uy component is 3. I'll write it in vector form. Is something missing? I want to write in vectors. So what is missing? Can anyone tell me? How to give direction along x-axis and y-axis? How to write? When you come to know it looks like a vector. And which letters are there? Will simply give me 7. Along x-axis, which unit vector we use?
I.
Yes. So always for x component, just put I cap, and for y component, just put j cap. And this is how you will get your initial velocity in terms of vectors. Now let me calculate for final one. Final one is simple. Final one will be Vx, V will be same as Vx plus v. So whether I check here or whether it's like just before reaching the ground, okay? So it's like calculated here. This will be a Vx, this will be a Vy for final. Can anyone tell me what will be Vx? Horizontal component throughout the projectile motion. It will be same as what? Vx will be same as this. I told you it is always the same. Horizontal fellow. If I'm starting with Ux, till at the end, what will happen? What will be Vx equals to?
Ux.
Yes, very good. So throughout, it will horizontal will always remain same. So Vx will be same as Ux. It will never change. So how much you had got? So that was 4. Vx will be same as, and Vy will always be in the opposite direction. So Vy will be, because here it was upwards, here it was downwards. So it's like you started with 4, then we had gone to 3, 2, 1, and I told you 1, 2, 3, and then it will be back to the same thing as 4. But only thing now it's in the downward direction, so it will be minus 4. Minus 3, sorry. So therefore, your total will be 4 I cap minus 3. Want you can write and keep, this is in downward direction. Otherwise here you write in why you took minus 3. So it will be same this. You can always, in terms of formula, if you want to write, it will be uy, vy will be minus u, ulta. So whatever you had got uy, take it negative, and then you'll get a final velocity vector. So this is how you have to calculate the problem. More I'll calculate in the next class. We'll stop here.